Good afternoon, everyone, and welcome to our 2024-2025 Winter Seasonal Outlook webinar. My name is Andrea Berg, and I will be your host for today's session. I'm just going to go over a few housekeeping rules before we get started. We are recording today's webinar, and I will be sending out a link to the recording to everyone who registered for this webinar when it's available. If you have any issues, technical issues during the webinar, you can reach out to me using the chat or the Q&A feature as part of WebEx. And we have reserved time at the end of the presentation for any questions you may have. And at any time throughout the presentation, please use the chat or the Q&A feature to ask your questions. So with that, I would like to introduce your presenter today, Stephen Davenport. He will be going over your winter outlook. Stephen?
Thank you, Andrea, and a very good day to you all. I'm Stephen Davenport, Weather Risk Communicator with the Long Range team at DTN, and welcome to our winter outlook for Europe and the UK. And this is what we're going to be looking at today. First up, a review of what last winter brought us. Then I'll run through the techniques that go into our seasonal forecast, including analogs, computer model outlooks, and look at what the polar vortex might get up to. That's always of interest. Then we'll have the DTN's official outlook for the winter, and we'll finish up with a quick look at the rest of the world and some industry impacts. A reminder then of what last winter brought us, with a quick review of the winter of 2023-24. After 3 La Nina winters in a row, we had a change. We had an El Nino winter, and this helped to promote a strong jet stream across the northern half of Europe, as you can see in the graphic on the left there, and down into Eastern Europe, with above average temperatures quite widely. So a mild winter overall, although it was closer to seasonal across northern parts of the UK, particularly Scotland, where conditions were more variable with occasional cold breaks. And on the northern side of the jet, over Scandinavia, Finland, northwest Russia, these were areas that were notably colder, open to more Arctic outbreaks. And a split in the jet came later in winter, with one branch shooting into southwest Europe, bringing an active pattern farther south as well. The upshot was further cold across similar areas of northern Europe in January, particularly over northeast Europe, Finland, and northwest Russia. And there were somewhat chillier conditions for northwest Europe around seasonal, and that was mostly due to a colder period in the middle of January. But there were above average temperatures for much of the rest of Europe, warmest in Spain and Portugal. In February, the right-hand graphic, mild conditions expanded, and we got rid of much of the cold anomalies in the north. The east and southeast Europe ended up very mild with respect to normal, even warm. With the active jet stream, though, it meant there was a frequent succession of low pressure systems, bringing plentiful precipitation across the northern half of Europe, as far north as southern Scandinavia, particularly in December and February. And in February, the southerly jet branch took plentiful rain further south into southwestern Europe. January had pockets of above average before February became very wet again across much of Europe, including the southwest. So plentiful rain for Portugal, western side of Spain, across France, into the Alps, Germany, and so forth. Driest areas were in southeast Europe, along with the warmth here. So this was the situation across all 3 months, December to February, which picks out the sharp temperature contrast from north to south, and the unusually mild, even warm conditions experienced across southeastern Europe, with the demarcation line of the jet stream and its attendant low pressure systems between the warm and the colder air masses. This active pattern also shows up well in the precipitation anomalies on the right there. with drier than average conditions around southeast and central southern Europe. The renewables, again, because of those frequent low pressure systems and the active jet stream, there were above average winds for the winter across parts of northern, central and eastern Europe, but below normal for Norway, slightly below in Spain, although there was better wind there later in the winter. Solar is always difficult in winter, but the best sunshine was under high pressure ridging in southeast Europe. Now, due to the mild conditions, there was a paucity of low-level snow across much of Europe, despite the elevated precipitation amounts in many areas. But regions from the far north of Scotland to southern Scandinavia into northeast and eastern Europe were both cold and wet enough for average to above average amounts, and parts of the Alps were close to seasonal. Closer look now at the UK's average temperature and precipitation for December through February. This highlights the milder than average winter, except the northern half of Scotland, which, as I noted, is very variable last winter and more susceptible to occasional cold intrusions. We can also see how wet it was for most of the UK and very wet for the Midlands and eastern Scotland. One interesting note is that eastern Scotland was wetter than the west, and that's due to easterly winds around the northern side of low pressure systems, given the particular track, which is more across Ireland, England, and Wales. As we've already seen, winds were above average overall in the southern half of the UK, closer to seasonal in the north, so decent for renewables. And well, this upcoming winter should be, as we will see. Now, this shows the ups and downs of the temperature last winter. There were cold, wintry outbreaks right at the start of winter for about the first week of December. And they returned in mid-January, which lowered the average for January as a whole. But the longer, mild stretches you can see there easily outweighed the cold interludes for most of the UK, hence the overall mild weather, except for northern Scotland. There were some very windy, even stormy periods. 3 named storms hit the UK and Ireland in December during those milder periods, with another couple coming through in January. Well, that's behind us, so on now to what we think lies ahead. El Nino is long gone, and we have a weak La Nina forecast for this winter developing as we speak. The stratospheric polar vortex is stronger this winter, although some weakening might be a risk late winter into early spring. Unusual warmth in the Atlantic Ocean is still a feature, and the sea surface temperature anomalies in the northern Pacific are similar to what they were last winter and have been for quite some time. That's a negative phase of the Pacific Decadal Oscillation, the PDO. There should also be another active storm track across the northern half of Europe for much of the winter. And a reminder now of the last couple of months' trends. August was warm or hot, even very hot across most, in some areas, but warm or hot for most of Europe, with notable heat and dryness, particularly across the eastern and southeastern parts of the continent. Temperatures 4 to 5 degrees above average for the month, with some very strong spikes and record-breaking heat in places. And drought conditions were exacerbated, especially around southeastern Europe, the Balkans and so forth. The exception was the northern and western UK, to southern Scandinavia, as anyone living in those areas will attest, where this active storm track from the Atlantic brought heavy rain at times and subdued temperatures. In September, the strongest heat transferred to Far Eastern Europe and Western Russia, but most of Europe stayed mild. With the exception of France and the UK, now it was cool in those areas, with northwesterly flows periodically developing in a more blocked regime. And that blocking brought sluggish low pressure systems to continental Europe. And that accounts for the copious amounts of rainfall you can see there on the analysis. with flooding in places, particularly due to Storm Boris, which developed in the middle of the month. Soon after that as well, in early October, the ex-Hurricane Kirk brought further heavy rain, especially to northern parts of Spain, Portugal, France, and into Central Europe. Those storms and the associated rain will have brought at least a little alleviation to the drought situation in Europe, but up to mid-September, this was the situation with Southeast Europe, the Balkans, Black Sea, Ukraine, and parts of the Med under critical and severe drought. Storm Boris brought some recovery to Eastern Europe, mainly parts of the Alps, Slovenia, Austria, Slovakia, Hungary, those kinds of areas. But it looks like drought will continue to be a problem for Southeastern Europe. Now on to the seasonal forecast itself. And we'll start with the main influences on the winter season. First of all, there's ENSO, the El Nino Southern Oscillation. That's the oscillation between El Nino and La Nina states in the equatorial Pacific. And that's typically one of the largest contributions globally. 40% is typical, sometimes more, sometimes less. And this year, less because we're expecting a weak La Nina. But predicting the ENSO state has pretty good skill. The polar vortex contribution has fair skill, and that accounts for about 30%, especially when conditions are right. Not something that can be pinpointed far in advance, but there is some skill in identifying the conditions under which polar vortex disruptions might become more likely at some point during the winter. Predicting disruptions themselves and their impacts is more something for a couple or 2 to 3 weeks ahead. So a sub-seasonal influence, and other sub-seasonal factors, things like snow cover and the MGO, those are pretty low skill and are a low contribution. And then there are the trends, what's happened in the last few years or the last 5 or 10-year periods, and we're looking at pretty good skill when we consider those. So on to teleconnections and our main seasonal drivers. Well, first, just to set the stage, what are teleconnections? You're probably all very familiar, but these are patterns driven by large-scale ocean-atmosphere interactions, and we have some of the main ones marked here. Atmospheric connections over vast distances mean that phenomena in one part of the world can have an effect in a very distant other part. The most well-known of these is the ENSO, as already mentioned, which shows up clearly in this seasonal forecast of global sea surface temperatures. This is from the ECMWF model for December to February. Those cool waters west of North and South America, indicative of the La Nina that we are expecting for this winter. Just a quick schematic of the 2 ENSO phases, showing the pretty much opposite circulations associated with La Nina, top left, compared with La Nina, I should say, and El Nino in the bottom right. So you can clearly see how these could affect large-scale circulation patterns elsewhere around the globe. Now, casting our eyes back to that cool equatorial Pacific water, the La Nina that we're heading for this winter, it's already starting to develop with an ongoing cooling trends. We should see weak La Nina conditions arise as we go through November, lingering during December, but then it should start to dissipate fairly on in 2025 and move towards a more neutral state by the spring, or at least by the second quarter of the year 2025. Looking over in the Atlantic, we have a positive phase of the Atlantic multi-decadal oscillation, the AMO, and that results from widely above normal temperatures that really have persisted for a long time now. Aside from a couple of cooler blobs south of Greenland and in the South Arctic Ocean. Note while we're looking at the Atlantic, the anomalous warmth elsewhere in the Arctic, though, that includes the Barents and Kara seas, which can sometimes have an influence on late winter conditions as well, as we'll see. In the Indian Ocean, there's the IOD, that's the Indian Ocean Dipole. That's a measure of temperature differences of the sea surface temperature between the Western Indian Ocean off the east coast of Africa and the Eastern Indian Ocean near Indonesia. It's expected to be pretty much hovering around neutral this winter, so it isn't being given a whole lot of weight. But then in the Northern Pacific, we have a negative phase of the Pacific Decadal Oscillation, or PDO, and that means warmer than average seas, but with a strip of cooler water along the western coast of North America. So if we look at years in the past that most closely match these and other drivers, we try to get an idea of what might occur through the coming winter. Matches are often hard to find, especially with such strong warmth in the Atlantic, but there's certainly value in finding the closest. In addition, we have a strongly positive QBO state. That's expected to continue on average through the winter, probably strongest in early winter, maybe moderating a little through the season, but no notable weakening. That's the quasi-biennial oscillation, and that measures winds above the tropics in the lower stratosphere. And when that's positive or in its westerly phase, it tends to encourage a stronger stratospheric polar vortex. Other influences are, as I quickly mentioned, the Arctic sea ice cover, especially the Barents and Kara seas, Eurasian snow cover, and also solar activity, which we'll come to in a minute. Low sea ice and a bigger buildup of early season Eurasian snow cover can be correlated sometimes with risks of a weakening stratospheric polar vortex. So there's things that'll need to be watched this winter, but those are going to fight against what could remain a strong polar vortex until later in the winter. Now, if we do get a weakening in the polar vortex, it can allow high pressure builds, for example, near Greenland, Iceland, and across the Eastern Atlantic region in general. The negative state of the North Atlantic Oscillation, or NAO, which can be a predictor of colder outbreaks, at least in the subseasonal range. So what do we have favoring a warmer winter, or milder than average at least? Well, firstly, we have the positive AMO, the warm seas in the Atlantic, the negative PDO phase, and the strong stratospheric polar vortex, at least until later in the season, where there might be some weakening risks. But if the Northern Atlantic finds itself more strongly or persistently warmer than normal, the north of the North Atlantic basin, that is, we could see greater risks of northern blocking developing and negative NAO patterns could emerge. And that would bring colder risks to the forecast, but still more likely in late winter than early winter. As it says on the tin here, years with similar La Nina and a warm Atlantic have mostly had above average winter temperatures, but have also had colder late season risks in Northern Europe. Back to La Nina, a weak and relatively short episode is anticipated, which might limit the impact downstream in Europe somewhat, although we can still find some correlations. An east-based La Nina with the coolest seas near the South American coast, Nino region 1-2, is more favorable for blocking patterns to emerge in the eastern North Atlantic sector. So that would imply chances of high pressure blocks near Greenland or in the Fenno-Scandinavian and Ural regions. However, having said that, you might have noticed from the sea surface temperature charts, a more centrally based La Nina is forecast across the Nino 3-4 region in the middle of the Pacific there. And that tends to shift northern hemispheric blocking features further west. So it looks like that could be less of a risk than during usual La Nina years this season. So here are predictions for the ENSO forecast from various modeling centers across the world. And the average here is represented by that thick and dark line. You can see just about dipping below the minus 0.5 degrees Celsius threshold for November and December. The largest consensus of models is right around that kind of point, but there are one or two showing a stronger La Nina and a couple of outliers in the other direction showing no La Nina development. So most likely we'll have a weak La Nina peaking in late autumn and early winter, and then that will gradually weaken through the first and second quarters of 2025. Another way of looking at La Nina predictions from the main global models, December forecast on the left, February on the right. To varying degrees, they're showing weak La Nina, including the average of all the models, but some are barely or not even quite reaching the threshold, although none are out on the limb with a strong La Nina, with most showing a weakening starting as we get to February. So it gives us some confidence on a weak rather than a strong La Nina developing. Here's a look at the various typical patterns of El Nino and La Nina at various times of the year. The one that matters to us is the bottom center, which depicts an active jet stream and storm track from eastern Canada to the northern UK, southern Scandinavia, not far off what we're expecting, although our forecasts tend to have this jet stream track a little further south. The AMO now, that's the measure of Atlantic sea surface temperatures in the North Atlantic basin. It's remaining strongly positive, near record warmth in the North Atlantic. Currently, it's not quite as warm as 2023's record, but still well above average and well above other warm years. And this kind of extreme warmth makes it a little bit of a challenge to find good analogs. La Nina has some correlation with positive winter temperatures across Europe, as shown on the left here. While the positive AMO has stronger correlation with positive temperature anomalies in the northwestern parts of Europe. PDO has a negative correlation, so the negative PDO that we've got indicates positive wintertime temperature anomalies for much of Europe, especially Northern Europe. The QBO has a weaker linkage, but a positive QBO does correlate with a milder winter in general, hence colder risks later in winter if there were to be a negative QBO. But as I said, we're expecting positive through most of the winter, well, right through the winter, in fact. Just a quick glance at the Indian Ocean dipole. Currently seas are slightly cooler in the Western Indian Ocean and the east, so the index is verging on a weak negative, which the graph top right and the December forecast bottom left are showing. But overall, more likely neutral through the winter, as depicted by the February forecast down there in the bottom right. So it's not a large influencer on our forecast this winter. I've mentioned the NAO previously. These maps show the correlation of air temperatures on the left, while on the right is correlation of the Arctic oscillation, the AO, a kind of a related phenomenon. So we can see the significance of identifying positive and negative phases of the NAO and AO for their impact on wintertime temperatures. Now, one more thing we mustn't overlook is the solar cycle. That can be a factor in determining the probability of the NAO state via its connection to the stratospheric polar vortex. And from this chart, you see that sunspot numbers are high despite a recent quick drop, and we're near the maximum of the solar cycle. Now, along with the positive QBO, years when the solar cycle is near maximum, along with that positive QBO, but tend to result in a strong polar vortex, at least until late winter, when disruptions could still be possible. So this lends some credence to the idea of low risks of block patterns and cold outbreaks through the early to midwinter, but doesn't rule out the possibility in later winter. And here's a reanalysis of February's that had above average sunspot numbers, showing mild conditions across South, Central and Eastern Europe, but maybe some cooler chances in the Northwest there. And on the right, the seasonal correlation with the solar index. As mentioned, the state of Arctic ice, the Arctic sea ice coverage can play a role, with the low coverage leading to risks of later winter cold. At the moment, we're at about record low ice extent. So it's certainly something to keep an eye on for late season. Another correlation map, I touched on Eurasian snow cover. Here's a correlation between high or rapidly increasing snow and negative temperature anomalies across much of Europe. So one more thing to look out for through the early to midwinter for an impact later in the season. Now, granted, just a handful of years here, but these give some useful hints. Perhaps these are years of stronger polar vortex, which we're expecting for at least midwinter, alongside a positive NAO state and a strongly positive AMO. So strong polar vortex, positive NAO, strongly positive AMO produce this kind of picture. Surface pressure on the left, showing a low pressure track and the jet near the northern UK across to Scandinavia, and the resultant mild conditions allowed by that setup with a northerly jet track. And you can see the reanalysis showing that mild Europe on the right there. Quickly back to the solar maximum connection. An additional note here, although La Nina winters have a better chance than El Nino winters of stratospheric warming events and disruptions to the polar vortex, this year's La Nina, as we've seen, should be weak. And the strongly positive QBO is actually unfavorable through most of the winter. So less of a risk this season. But without those deterrents, the positive QBO, the sudden stratospheric warming frequency by month and by ENSO event looks like this, with greater chances during La Nina years in January, February, and March. Now the polar vortex, currently strong. We're looking at above average winds at 50 millibars, 50 hectopascals around the pole. It's not expected to change much in the early winter season. Later in winter, we see a bit of a wobble perhaps per these analogs. And by March, analogs are suggesting a weakening of these winds or even a reversal. So that would increase the chances of polar vortex disruptions late winter. I think we're kind of seeing a pattern here. There are many things pointing to at least a risk of polar vortex disruptions late winter, and therefore that time of the season where it's more likely to get sustained or significant cold outbreaks. No promises yet. Also predicting where any resultant outbreaks of cold will hit around the northern hemisphere is a problem at seasonal range has more of a sub-seasonal predictability. This is a typical strong and weak polar vortex position here. Strong polar vortex has pretty much circular winds around the pole, which locks in cold air up at high latitudes up in the Arctic. When the PV weakens, lobes can break off, carrying pockets of much colder air southwards. But just where these outbreaks occur, as I said, is determined by exactly where blocking high pressure ridges develop, and these are only really forecastable at the sub-seasonal or shorter range. The ensemble forecast indicating a stronger than average polar vortex from late October through November, continuing above or near average through December with no weakening on the cards through the rest of this year, according to the consensus at least. In early winter, the troposphere tends to lead the stratosphere, so we do need to watch for any high pressure blockings, things like a strong Scandinavian Ural ridge building, as that could be a precursor to weakening of the PV at some point. But again, just to beat the drum again, more possibly in late winter, even in springtime, a stronger polar vortex tends to disrupt at some time in March, maybe late March and into April. So colder risks are possible when we get into early spring, perhaps. So putting all this together, we've come up with the following analogs of weather conditions from previous years with similar patterns that we're expecting this winter. So our analogues are based on weak La Nina, a very warm North Atlantic, strongly positive AMO, a negative PDO, and a positive QBO. IOD shouldn't be much of a factor in this. 3 of these years as also good analogues for the strength of the polar vortex, positive NAO and positive AMO. Moreover, a positive QBO, even with a slight weakening trend, is still warm for Europe, especially Eastern Europe. And this is where our analog years take the La Nina prediction, not far from the model forecast average we saw earlier, close to the same value at its peak, while peaking around the same time as well, and then slowly warming through early 2025. If you recall the ECMWF model forecast of sea surface temperatures, then you'll see that our analogs are a pretty good match for that as well. So they show the negative PDO pattern, perhaps a bit more cold near the western coast of North America, but also the positive AMO with anomalous warmth right across the Atlantic, except around Iceland there, and the cool waters of the central base La Nina in the equatorial Pacific. And what do our analogs show across Europe for temperature and precipitation? Well, for December, lots of orange and red showing there, so widely above average temperatures, most anomalously warm in Central and Eastern Europe, we think. Storm track indicated from the UK and Ireland to southern Scandinavia. So a parade of low pressure systems bringing above average precipitation for those areas, especially from the northern UK to southern Norway. January is similar, just with a bit more cold getting into northern Scandinavia as the jet slips southwards, which would also spread anomalous precipitation farther south into mainland Europe. February has that trend continuing with some colder outbreaks getting into more of Scandinavia and the northern UK and Ireland, but overall near normal temperatures with a strong variability between cold and warm spells. Elsewhere in Europe, remaining mild, even warm in places in southeastern Europe, and wet for many areas, except for much of the Mediterranean. Look ahead to March. There's a shift in patterns to bring wetter and cooler conditions to southwest Europe, Central Europe, and the Med. It's unlikely to pan out just like this, but indicative of the sort of shift that could produce colder outbreaks, potentially a more blocked setup. December to February overall shows, well, an unsurprising pattern. Lots of warm anomalies, especially in Eastern Europe, wettest conditions across Northern Europe, but some above average precipitation in Central and Eastern Europe as well. For snowfall, analog years are showing below average snow cover for much of Europe due to the wet but mild conditions, especially low-level snow. It ought still to be cold enough though in Scandinavia for wetness to translate to near or above average snowfall amounts. Parts of the Alps should be closer to seasonal, but kind of tricky to nail down because they're on the edge of the wet and dry analog predictions north to south. Next ingredient goes into our forecast mix is the global weather models, predictions from several computer models of the large-scale weather patterns across the winter season. First, though, we'll take a quick look at the next few weeks. Pressure pattern forecast by ECMWF looks like this, with high pressure becoming more dominant near the west of the UK and Ireland next week. An Atlantic ridge pattern possibly, which brings a chance of a chillier period through about the first 10 days of November. Then shifts a bit north and northwestwards in week 3, that's early November, before becoming less dominant mid-November as low pressure potentially develops. And here's a way of looking at possible Atlantic European regimes by ECMWF. The regime probabilities. Here you can see in purple the increased Atlantic ridge regime possibilities early November before the positive NAO pattern, that's the blue columns, becomes more likely by mid-November. So the first part of November, a chance for some chillier conditions in western and northwestern Europe. before becoming milder again in the middle of the month. Results look like this next week. That's week 2, having those cooler northwest flows across northwest and West Europe, and potentially a bit colder than shown for the UK and Ireland if ridging to the west is stronger, but warm flows still affecting Eastern Europe. There could be a cut-off low over the Med and Southeast Europe, though. Upping the precipitation amounts, bringing some drought relief, even if marginal, to Southeast Europe, and some decrease in wind across Northwest Europe. More of a drop in wind comes in week 3, though, with the first 10 days of November having a cooler and calmer period over Northwest and Western Europe. So maybe a little increase in demand while renewable supply decreases, although I would not expect it to be notably cold or for too long. Winds pick up again in week 4, mid-November, as high pressure shifts away and it becomes mild in most areas, but cold in Norway. A quick look at the tropical Atlantic to see if there are any developments possible later next week, end of October into early November. Models are suggesting there's a chance of tropical convection developing, so something to look out for. There's any recurving storms always have a chance of disrupting the expected patterns. So you can see an uptick in activity around the Caribbean, which may drift north into the Gulf of Mexico. Anything that develops might recurve northeastwards across the Atlantic, and we've seen what kind of effects that can have. Not saying we'll get another ex-Hurricane Kirk, but always something to bear in mind with the hurricane season continuing through November. If we look even further upstream, any strong typhoon could disturb patterns into North America with potential knock-on effects downstream across the Atlantic. Also, the West Pacific phase of the MJO, that's a Madden Julian operation, a pattern of tropical convection that circles the Earth. That supports Atlantic European high pressure patterns. So again, the possible Atlantic ridge and temporary stronger negative NAO could lead to those colder risks for a while in early November. Now, the seasonal models for the next few months. First, the ECMWF month-by-month outlook. That shows a consistent above average temperatures right across Europe. Of course, it's unlikely to look exactly like this with models not picking out timings and areas of any colder pockets, even if they are temporary. So still mild overall. December looks wettest in Norway, then much of Central and Western Europe is rather dry indication, but February turns wetter, likely the wettest month before a somewhat drier March with some colder risks developing there. Rather low winds shown by the ECMWF until a pickup in February, along with, along with the precipitation. High pressure, largely dominant in the ECMWF outlook until late winter and returns to Northwest Europe in March. The CFS V2 model, that shows a little difference in the temperature anomaly pattern, also depicting above average temperatures each month across Europe, with February also looking the wettest of the 4 months, although less so perhaps than the ECMWF. More wind evident in the CFS V2 model anomalies across at least Northern Europe, and then more of Europe during February, along with an uptick in precipitation. And this is broadly consistent with what the ECMWF was showing. One more model to look at, in fact, a multi-system model based on the models of the main European centres that depicts a similar pattern to our analogues for the winter period, the low pressure track on average, the northern UK into Scandinavia, eastern and northeastern Europe, shown on the left, and widespread warm anomalies across Europe on the right, but particularly for eastern and northeastern areas. Gathering all this together, that's the models, the drivers and analogues. We'll finally get on to our official forecast, official DTN forecast for the upcoming winter. And we compile the forecast by taking the climatology, narrow that down to the trends over the past decade, then relate this to statistical analogs from the teleconnections and some of the seasonal computer models to create our final forecast solution. And given what we've already seen, it's not going to come as much of a surprise that our forecast is for above average temperatures across Europe for each month individually. But bear in mind that proviso that I've already mentioned, confidence being lower for late winter and early spring. So there are colder risks to the forecast in February and as we go into March, even April, especially if we get any disruptions to the polar vortex. Equally unsurprisingly, that means winter as a whole is forecast to have above average temperatures. The strongest anomalies in central and eastern areas, and the probability forecast suggests reasonably high confidence in the forecast to February. We need to look at the risks as well, though. We run several scenarios, and the warmer one naturally is even warmer than our forecast. But notable that the coolest scenario still depicts above average temperatures, meaning a low risk of a colder outcome for the winter. A different evolution of La Nina could impact the forecast and skew it cooler. So we must keep bearing in mind the factors leading to potential colder risks in late winter. For later winter into the spring, although this exact pattern in the colder scenario is unlikely to evolve just as it shows here, it does give indications of some colder chances that might develop in late winter and into the early springtime. Looking at the forecast pressure patterns, our forecast has a low pressure track from around Scotland to southern Scandinavia by December, more high pressure dominance in January, then low pressure returning to northern and northwestern Europe in February, which is leaning a bit more towards the analogs and the model blend, although February is more similar. The precipitation outlook looks like this, with that low pressure track giving above average precipitation from the UK to Norway in December and dryness in Southeast Europe again, so problems with drought potentially. More widespread above average precipitation develops for February before a potentially drier period in March, although the anomalies are a bit washed out there. For the winter as a whole then, here's the precipitation pattern, wetter than normal across northern Europe and drier in the south. And so I clicked through too many slides there. There we are, there's the precipitation pattern for the winter. And for renewables, winds following the precipitation pattern, so the UK to southern Scandinavia and northeast and far eastern Europe should have above average winds in December, but some decreases in January. February looks like being the windiest as well as wettest month across northern Europe, although only in southern Scandinavia with less wind, excuse me, less wind and precipitation for northern parts of Scandinavia, and good winds extend into Central Europe. Solar is less significant and harder to pin down, but given the expected pattern, then solar could be best in Southeast Europe. The winter as a whole then looks like this: good wind production across the northern half of Europe, no better than average in the south, and some places potentially below. Way back we had a quick look at expected snowfall, concluded that for much of Europe, despite above average precipitation across northern and central regions, the snow should be below average because of the expected mild conditions. But to reiterate, Scandinavia should be cold enough for average to above average snow amounts, given the low pressure track into Scandinavia, and the Alps could be near seasonal, but confidence is rather low. This rather neat infographic sums up our official DTN forecast, and I'll just leave that up for a short moment while I just catch a quick breath. I'll look at the global picture, and what stands out is a lot of warm anomalies across the world. for the Northern Hemisphere winter, Southern Hemisphere summer. A hot summer in the offing for Northern and Eastern Australia, and parts of South America, but very wet bullseye there in Northern South America. Across North America, warmth in the south and east, cold intrusions in the northwest and central north. Note, though, that for the Northern Hemisphere, the overall mild disguises the potential for temporary colder outbreaks, which, as we've seen, are not really predictable, can't be pinpointed, the seasonal range. Another infographic here. Now there's interest in the US, so a little more detail for the USA. Mild winter across southern and eastern US, warm and dry enough for wildfire risks to be exacerbated in the southwest. Coldest areas going to be in the northwest with high amounts of rain and mountain snow expected, and as it says here, big ticket storms are on the menu. Northern US should have shorter but potentially potent cold shots in between longer, milder interludes. Should have quite a snowy winter as well with an active low pressure track. In the northeast, the pattern we're expecting should mean less lake effect snow than normal. Not ruling out entirely, but fewer of those events than average. The northeast should have a less snowy winter than normal, with relatively mild conditions, and New England and Mid-Atlantic have lower chance of frequent coastal storms and of nor'easters. Southeast should be warmer than normal, but brief colder shots are possible. And when they occur, they could be sharper than usual. So maybe counterintuitively, there could be actually be a greater risk of frost and freeze in Florida. So here are the key takeaways from the forecast. Weak La Nina, trending towards neutral, towards spring. The warmth in the Atlantic, strongly negative PDO, positive QBO, and a strong polar vortex, at least through early to midwinter, all going into our forecast, which has moderate confidence for the south and east, lower in the northwest with more uncertainty and more variability likely. Analogues and models suggesting above normal temperatures throughout the winter across Europe. Colder outbreaks are possible, but at any time, but any more significant ones would be more towards later winter, we think, and that rather dependent on any weakening of the polar vortex late winter and sudden stratospheric warmings. Wetter than normal across the northern half of Europe with above average winds and potential for some impactful systems. So we shouldn't be surprised at named storms developing across parts of Europe. Drier and somewhat calmer southern half of Europe. And less lowland snow than usual, but above average amounts at higher elevations in North Europe and at lower elevations in Scandinavia. Finally, a quick glance at any industry impacts. For utilities, the mildness of the winter should mean below normal demand for energy, except for any colder late winter or early spring risks. Good wind production for the northern half of Europe, above average solar possible for southeast Europe, but an increased risk of strong and potentially disruptive low pressure systems across northern, western, central Europe in particular. For transportation, that mild winter should mean fewer actionable nights than usual, with fewer instances of frost and ice, at least until late winter. So potentially less treatment necessary, at least across the bulk of Europe, maybe not the case for Scandinavia, but more risk of disruptive wind and rainfall events as well. Less snow in most areas than average, possibly more at higher elevations than northern UK, northern Scotland may be more susceptible, and as mentioned, Scandinavia having at least a near average or above average wintertime snowiness. And now, with that all said and done, we'll invite any questions.
If you have any questions, feel free to put them in the chat or the Q&A.
I do have one question here, Andrea. You mentioned the strong QBO phase. Is there any chance that this will weaken enough this winter to allow more weakening of the polar vortex and a greater chance of cold? Um, good, good question, but in short, we can have reasonably high confidence in that aspect of the forecast and that it won't weaken significantly at all. The QBO, just to remind ourselves, is the lowest stratospheric wind above the tropics, currently in a positive westerly mode and quite strongly so. And the chances of a rapid weakening or even reversal to an easterly flow are slim to none in our winter timeframe. It advantageously, it's one of the more predictable phenomena we look at, with a fairly regular cycle of 28 months between phases. So its predictability gives us rather high confidence. Maybe something to come under consideration next winter, but we're not going to go there yet.
I see another question. Is the drought in Southeast Europe likely to continue?
Yeah, despite that heavy rain in September, bringing some relief, the forecast, as we saw, is still for drier than average conditions overall through the winter around Southeast Europe and the Balkans area. So drought is likely to remain a problem right through to next year. It may be kind of counterintuitive to talk about it while we're looking at a winter forecast, but not just drought, but a continuing wildfire risk as well, especially as you get back into the warmer months next spring.
Another question came in through the chat. When do we see the lowest temperatures forming as an estimate? And I believe this is for the UK.
Oh, for the UK, yeah. Well, climatologically, our lowest temperatures are in February, and in fact, seems the most likely period this winter. Somewhat dependent. I mean, it's not showing anything particularly cold at the moment, but with respect to normal, those temperatures, even if near average or slightly above, are still going to be, of course, lower than December, January. But February is the time where we're perhaps coming into the risk of colder outbreaks if we should get polar vortex disruptions. Then February could be the coldest point of the winter. Having said that, if any such disruptions get pushed back, it might even be early spring before we see coldest outbreaks, so maybe even into March, but late winter and into early spring in any case, we could potentially be the coldest period.
And another question I see, how much longer will the hurricane season last? Any chance of another ex-hurricane impacting Europe?
Yeah, always saw in the presentation some chances through the second half of next week of developments near the in the Caribbean and perhaps in the Gulf of Mexico, with an increase in tropical forcings possible. And we've also seen how much warmer than average the equatorial sea surface temperatures remain, and indeed across the Atlantic at large. So that kind of warmth is going to be hard to get rid of. So it could mean an extended hurricane season, certainly all the way through November. It depends on other factors, of course, like having the necessary low wind shear. But if that's favorable for development, and we have enough like convection, then more tropical systems are possible until quite late in the year. Whether they turn and recurve across the Atlantic to affect weather patterns and wind and precipitation in Europe, there's not something we can be sure about until they start to unfold. But it's not impossible. We see something like another ex-hurricane recurving and pumping up conditions into Europe.
I don't see any other questions that have come through. If anybody has any questions, you can use the chat or the Q&A feature. Usually it's located on the right-hand side of your screen. There might be a button at the bottom that allows the chat to pop up.
I see a quick question about there may have been thoughts of a front-loaded winter in the UK, cold start possible. Yeah, I think it's not looking like the case at the moment, aside from this potential for fairly short-lived chillier periods in November. And I think potentially, as the questioner points out, due perhaps to a weaker, a rather weak La Nina development.
All right. Do you see any other questions? I do not.
I do not see any further questions. And thank you
Excellent.
all for your questions.
Yes, I want to thank everybody for joining us today for this very informative look into our winter forecast, long-range forecast. This presentation has been recorded, and we will send out a link to the recording if you want to listen to it again when it is ready. So I want to thank you all and have a great rest of your day. Thank you.